A colossal stone wall. It's a silent challenge, really, to our whole timeline. What if the history we know is missing its most brilliant chapters? This is a global journey, 30 ancient structures. They reveal engineering capabilities so advanced they still baffle experts today. By the end, you'll see human history, not as a straight line, but as a forgotten tapestry of genius. It alters how you view our past. How did cultures across the world move stones? Stones heavier than modern cranes can lift. What knowledge allowed them to build with a precision we struggle to explain? The evidence is carved in stone. It's waiting for us to listen. What does true mastery of the physical world actually look like standing in front of the Great Pyramid? It's humbling. You're dwarfed by the size, but also by the silence, the geometry. It's not just a tomb, it's a statement. A mathematical statement, an engineering statement, carved right into the land. The numbers are staggering: 2.3 million blocks. Limestone, each one weighs several tons, lifted, locked into place. But the real mystery isn't the weight, it's the precision. The base is almost perfectly level. That's a surveying feat. It seems to defy its age. The sides are aligned with the cardinal directions, within a tiny fraction of a degree, pointing to true north. It suggests a deep understanding of the earth. How did they do it? The conventional picture, thousands of workers, earthen ramps, that picture starts to strain under the weight of that exactitude. Engineers like Christopher point to the evidence. In the stone itself, the joints between the massive core blocks, they're so tight, so meticulously fitted, you can't slip a piece of paper between them. That's a level of craftsmanship. We associate that with fine cabinetry, not with megalithic construction on this scale. Then there are the internal chambers. The king's chamber, built from enormous red granite beams. That stone was hundreds of miles away. Each beam weighs as much as 70 tons. The logistics, transporting them by river, raising them, positioning them deep inside the pyramid's heart, that's still debated. Consider the coordination. The traditional timeline says the whole project was done in about 20 years. That means quarrying, shaping, transporting, perfectly placing one of these multi-ton blocks every few minutes, day and night, for 2 decades, while maintaining a margin of error, less than 1 inch, across a structure covering over 13 acres. It's a rhythm of labor and genius. It challenges what we think an ancient society could do. The Great Pyramid sets the bar. It's a standard of silent, enduring mastery. Every other ancient wonder gets measured against it. And that same standard, it appears in unexpected places. All over the world, that same standard of mastery shows up somewhere that feels completely different. Up on the Bolivian Altiplano, over 12,000 feet up, the air is thin. It's cold. This is Puma. It doesn't look like a building. It looks like a giant's box of stone puzzle just thrown all over the ground, scattered. The ground is covered in these slabs of andesite and red sandstone. Some of them weigh over 100 tons, but it's not the size, it's the condition. These stones look like they were machined. They have these razor-sharp edges, perfect right angles, complex geometric channels cut into them, all with a consistency that shouldn't be possible for that time. The most famous ones are the H-shaped blocks. They aren't random. Each one is a precise template, a repeatable template with uniform grooves. With these perfectly drilled holes that line up, it points to a system, a prefabrication system, where one block was made to interlock with the next one, like parts of a big modular assembly. This isn't rough stonework from some early culture. This is advanced engineering, a language of precision, of mass production, written in stone thousands of years before the industrial age, and that's the real mystery. The conventional tools they say the culture had are simple: stone hammers, bronze chisels. Using those on andesite, which is as hard as granite, to get work this flawless and intricate, it's a profound puzzle. Try to picture doing it, creating those perfectly flat surfaces, those precise interior corners, those symmetrical recessed channels, with hand tools. The skill and time that would take is almost unimaginable. It forces a hard question. Were the builders using a technology we just haven't recognized? A lost method for cutting hard stone that gave a result eerily close to modern machining. Then there's the state of the site. It isn't just ruins worn down by time, it looks shattered, like it was hit by a colossal sudden force. These massive multi-ton blocks are just strewn around. Some look torn right out of their foundations. That's led to theories about a cataclysmic event, maybe a huge seismic upheaval. or a catastrophic flood from a nearby lake. The destruction adds another layer, a haunting one. It feels like you're walking through the aftermath, studying the broken parts of a magnificent machine, and we can only guess what it was for. What were they building here at this altitude where every breath is labored? A temple, a grand portal, something for astronomy? The precision implies a function, a need for that exactness. But the answer is buried, lost under the rubble and the centuries. Puma stands, or really, lies fallen as a stark challenge. It whispers that our tidy models of human progress, of slow, linear technological advancement, they might be missing entire chapters. Chapters where someone somehow achieved a level of stonework we still struggle to explain. The walls they rise above, not a straight line but these jagged teeth like they're biting the sky. And the stone itself, it doesn't make sense. You're looking at a single block of limestone, taller than a person, wider than a car, over 100 tons. And then you see it's just one piece, part of this massive three-dimensional puzzle. Every stone is a different shape, an irregular polygon, all these angles and facets, but each one fits against the next one. The seam between them is so tight. After 500 years, you still can't slide a blade in there. There's no mortar holding it. The binding is just geometry, the fit itself. This is polygonal masonry, the most advanced kind. And it wasn't just for looks, it was seismic engineering. The Inca lived where earthquakes happen. A straight, rigid wall would crack, it would collapse from the shearing force. But a wall like this, with its zigzag shape, all these interlocking pieces, when the ground shakes, the stones don't resist. They shift, they move, they settle back. The energy gets redistributed through the joints. It's a structure designed to flex, to breathe with the earth. That's an understanding of physics, carved right into the land. Which brings up the question, how did they get that fit? Researchers still debate it. One idea involves plants, local plants with acidic properties. The theory is they applied these compounds, maybe over and over, to soften the stone surface just enough, to allow for shaping, for polishing, using the chemistry of the land to work the stone of the land. Others point to something simpler. Supreme skill in stone dressing, teams of craftsmen, using harder stone hammers, bronze tools. Pecking and grinding each face of a boulder, a process of trial and error. Lower the stone, check the fit, mark the high points, grind them down. That demands immense patience, and a shared mental blueprint, a vision of the final interconnected wall. The coordination that implies is staggering, and before any carving could start, there was the journey. These megaliths came from quarries miles away. The logistics are hard to grasp, moving a 100-ton block up and down the steep Andes. The main theory involves manpower, ropes, leverage, hundreds of workers, maybe thousands, pulling on great ropes, others placing log rollers underneath. They might have built earthen ramps, inching each piece toward its place on the hill. It was a symphony of communal effort, a project that would have defined a generation. So you stand before these walls, you trace the cool, seamless joints with a finger. The effort is almost incomprehensible. Why commit that much labor, that much ingenuity and time? Was a fortress, but also a ceremonial center, a sacred space. That suggests the walls were more than defense. They were a statement of harmony, a declaration that this place, this nexus of spiritual and earthly power, was woven into the bedrock, designed to endure nature's trials. The walls stand not just as a barrier, but as a testament to a culture that sought not to conquer the landscape, but to converse with it in the language of stone. And if that language was understood here in the Andes, where else was it spoken? 800 tons. That's what a jumbo jet weighs fully loaded. And then you have a single block of limestone, cut from the earth, shaped by hand, lifted into a wall. That's the Baalbek. 3 of those stones side by side. They form the base of the Roman temple of Jupiter. The size is absurd. It feels like a statement. Architectural one-upmanship meant to echo through time, but the Romans might have been latecomers. They built their temple on an older platform, a foundation made of stones that defy logic. Not far away in the quarry, you see the real measure of that ambition. The stone of the pregnant woman, a monolith that was never moved. It just rests where it was cut free. A sleeping giant of limestone. Its weight is estimated at 1,000 tons. Standing next to it, you feel small in a specific way. You're not facing nature's randomness. You're facing human intention on a scale that borders on myth. The quarry floor shows the work. Trenches were cut around it, defining its shape precisely. The block was dressed. Its sides were smoothed and squared, all while it sat in its bed. This wasn't a rough draft, it was a finished product, waiting for a journey that never started. And the question hangs there, almost as heavy as the stone. How do you move it? Even now, with our most powerful cranes and transporters, moving a 1,000-ton block across miles is a monumental feat. a carefully planned engineering challenge. For an ancient culture, it seems impossible, but the evidence suggests they had a plan. The precision of the cut implies they believed they could transport it. Theories point to a system, a symphony of ancient engineering. They might have used counterweights and levers to tip it onto a sled. The path could have been lubricated, water or clay to reduce friction. Then the coordinated pull of hundreds, maybe thousands of people on ropes, inching the megalith forward day by day. It's a vision of communal effort that staggers the mind. The logistics alone, food, water, shelter for that workforce, all dedicated to moving one stone. It speaks of a society with extraordinary organization, a singular, unwavering purpose, which leads to the deeper mystery. Why choose the largest single stones ever used? Smaller blocks would have been infinitely easier. The choice seems deliberately difficult, almost ritualistic. That suggests the platform at Baalbek wasn't just another building site. It was a sacred space of immense antiquity, a place where the act of building was itself an act of devotion. The extreme effort was part of the offering. By moving mountains, they were perhaps trying to touch the divine, to create a permanent, unmovable connection between earth and sky. The identity of the original builders is lost, their name erased by the layers of history that came after. We're left only with their handiwork. A silent, staggering question carved in limestone. It pushes us to the limits of ancient ambition, to wonder what kind of belief, what kind of knowledge could motivate such a breathtaking physical testament. And as we think about these stones that seem to anchor the earth, the journey turns to a place where builders aimed for the opposite, reaching for the sky with a lightness that defies the very material they used. From a 1,000-ton stone to something that fits in your hand, that's a huge shift. From sheer mass to this intricate, layered complexity. In 1901, sponge divers found a shipwreck off a Greek island. They pulled up statues, ceramics, and then this lump of corroded bronze and wood. It looked like junk. For decades it just sat in a museum drawer. Then researchers started looking closer. X-rays and scans showed what was inside, a clockwork universe. At least 30 interlocking bronze gears arranged in layers. This was the mechanism. Built around 100 BCE, it's been called the world's first analog computer. Its purpose was to model the cosmos, to predict the motions of the sun and moon, the positions of planets. It could forecast eclipses. It even tracked the 4-year cycle of the ancient Olympic Games. You'd turn a hand crank and the gears would move. Dials on the front and back would spin, showing the celestial dance for any given date. The accuracy was stunning. It accounted for the moon's irregular orbit, a subtle wobble called lunar anomaly. To do that mechanically, they used a differential gear, a system that calculates the difference between two input rotations. That technology wasn't thought to be invented until the 16th century in Europe, but here it was, in a Greek device over 2,000 years old. This wasn't just a clever toy. It was a physical manifestation of advanced knowledge. It required deep astronomy to know what motions to predict. It required sophisticated mathematics to translate those cycles into gear ratios. And it required master-level metalworking to cut those tiny bronze teeth, some just a millimeter or two in size, and assemble them into a working machine. Scholars like Michael Wright have spent years building replicas just to understand how it functioned. Each gear tooth, each inscribed scale, is a word in a lost language of engineering. The mechanism shatters a comfortable assumption that complex geared technology is purely modern, that the ancient world was mechanically primitive. This one artifact tells us that wasn't true. In the workshops of Hellenistic Greece, likely in Rhodes or Alexandria, there were minds thinking in gears and cycles, building devices to comprehend the heavens. This was a technological peak, a flash of genius that then vanished for over 1,000 years, and that's the most haunting part. It was found in a shipwreck, a single copy lost at sea. How many others were there? How many other sophisticated devices, libraries of mechanical knowledge, were lost to time, to conflict, to decay? The mechanism is a survivor, a lone messenger from a past that was far more technologically adventurous than we guessed. It forces a humbling question. If this one device survived by chance, what entire chapters of human ingenuity have been completely erased? It suggests our timeline of progress isn't a steady upward slope. It's a landscape with peaks and valleys, with brilliant summits of knowledge that were reached and then forgotten. This discovery pulls our gaze from the monumental to the miniature, from stones that anchor the earth to gears that chart the sky. And it makes you wonder, if they could build this, what else did they understand about the world that we are only now beginning to rediscover? The desert floor is just reddish-brown pebbles. You walk on it and see these shallow trenches, maybe a foot deep. It looks like random erosion, but then you get above it. From a small plane, the view changes everything. Those scratches become a hummingbird. Its wingspan is wider than a football field, a spider with legs stretching hundreds of feet, a perfect spiral, a triangle that runs straight for over a mile. This is art on a geographical scale, designed for a viewpoint its creators could never occupy. The process seems simple. The people between 500 BCE and 500 CE, they didn't build anything up. They took things away. They removed the top layer of dark, sun-baked pebbles to expose the lighter, chalky soil underneath. The contrast does the work. From above, the lines glow. But that simplicity is an illusion. To create a figure over 1,200 feet long and keep its proportions perfect, you need a master plan. You need a way to transfer a small design onto a landscape so vast you can't see the end from the beginning. How did they do it without flight? Researchers like Maria, she dedicated her life to studying the lines. She proposed a method of scaling up. They likely began with a small model. Then, using a system of stakes and ropes, they could have projected that design onto the desert floor. Think of a giant compass and a straight edge, but on a scale of miles. They might have used prominent hillsides, the natural high points, as their surveying stations. Maintaining the curve of a monkey's tail or the joints of a spider's leg over such distances required a profound grasp of geometry. This was large-scale project management, executed with simple tools and collective memory. Their endurance is another kind of engineering. The desert is one of the driest places on Earth, minimal erosion from rain or wind. The pebbles they moved formed a protective layer. By removing them, they actually created a more stable design. The exposed lighter soil hardened in the sun. No vegetation meant no roots to disturb the lines. They built, in a sense, with the climate itself. They engineered for permanence using the very elements that would destroy a structure anywhere else. But the why remains the deepest mystery. Were they astronomical calendars? Some lines do point to celestial events like solstice sunrises. Were they ritual pathways walked by priests during ceremonies, their giant forms visible only to the gods in the sky? That idea is compelling. It suggests the art wasn't for human eyes at all, but for divine spectators. It represents a leap into abstract thinking. A culture so confident in their cosmology that they invested generations of labor into a message for the heavens. The lines are a form of communication, a prayer written so large it could only be read from above. The lines force a reconsideration of ancient perception. They are a testament to a different kind of vision, not aerial but conceptual. The ability to hold a giant, perfect image in the mind's eye and then imprint it onto the earth, trusting that its true form would be recognized from a perspective they could only imagine. It's a breathtaking act of faith. Faith in geometry, in planning, and in a universe they believed was watching. And if a culture could plan for a view they could never see, what other forms of knowledge were they acting upon? Knowledge we have yet to fully comprehend. The face inland. Their backs are to the ocean. They watch over the land, they watch over the people. They're carved from the soft volcanic rock of the quarry. These are monolithic human figures. Some are over 30 feet tall, weighing more than 80 tons, and there are so many of them, nearly 1,000 statues, in various stages of completion. Scattered across the island, the quarry feels like a workshop frozen in time. Some figures are still partly in the bedrock, still connected to the mountain. As if being born from the earth, others stand in trenches, finished but waiting. It's a snapshot of an industry, a cultural obsession captured in stone. The first puzzle is the carving itself. They used hand tools made of harder basalt stone. Called craftsmen pecked and ground the volcanic rock into these smooth, recognizable forms. The strong brows, the elongated ears, the set lips, all from that patient, percussive process. But carving was just the beginning. The true test was the journey. The completed had to travel, sometimes miles, across rugged terrain, from the quarry to their coastal platforms, their ahu. How do you move an 80-ton stone giant? Without wheels, without large animals, without modern machinery. Oral traditions and modern experiments point to methods, physically demanding methods. One theory involves a walking technique. Using ropes, teams could rock the statue side to side, inching it forward with each tilt, turning the statue into its own mode of transport, a slow, deliberate march. Other experiments show the feasibility of a sled or log rollers. with the path lubricated by sweet potatoes, by vegetation, to reduce friction. Each method shows a deep practical understanding of physics, leverage, friction, center of gravity applied on a colossal scale. The logistics are mind-boggling. It required a highly organized society, coordinating the food, the housing, the labor for teams large enough to pull these stones, managing the ropes, the pathways, the rhythm of the work. This was a society that had turned statue moving into a central, unifying endeavor. Then came the final act, the erection, getting the statue upright onto its stone ahu platform. This may have involved building a gradual ramp of stones and earth, painstakingly levering the statue into a standing position. And for some, the final touch was a separate cylinder of red stone, placed on top of the head like a colossal topknot, weighing up to 12 tons itself. Placing that capstone was another feat of precise engineering and balance. So what drove this society to pour so much energy into this stone chorus? The leading interpretation is that they represent ancestors, not gods but revered forebears. By placing them on the ahu platforms, which often served as ceremonial centers and burial sites, the living community positioned these ancestral watchmen along the coastline. They were a link between the present and the past, a source of spiritual protection, a source of mana or power. The statues were a physical manifestation of lineage, of identity. The story of the holds a lesson about balance. Archaeological evidence suggests the drive to create them may have contributed to the island's ecological strain. As forests were cleared for rollers, for resources, it's a reminder, a poignant reminder, of the complex relationship between cultural ambition and environmental reality. They stand today as majestic, enigmatic symbols of what humans can achieve through unity and vision. They also whisper a warning about the limits of an island or any world. They are triumphs of logistical genius, carved from both stone and spirit. And they force us to ask, when does a monumental cultural achievement become a weight? A weight the land itself can no longer bear. Granite is hard, it's crystalline, it resists shaping. But at Great Zimbabwe it was tamed. The walls rise from the earth in these flowing curves, built without mortar. Each block was cut and shaped and placed so precisely the structures have stood for nearly 1,000 years. This wasn't a fortress, not in the European sense. It was a city of stone, a center of power and trade built by the Shona people between the 11th and 15th centuries. The scale is breathtaking. The great enclosure, its outer wall snakes for over 800 feet. It stands up to 36 feet high. At the base, the wall is 16 feet thick, a massive gravity-defying ribbon of granite, and inside it the conical tower, a solid 30-foot-high structure. Its exact purpose is still a mystery. A grain silo maybe, a symbol of authority. Its presence is a statement. The engineering is a quiet marvel, the stonework itself. The granite was locally, then dressed using other harder stones. Craftsmen achieved a remarkable uniformity. The blocks were shaped into standard sizes, creating these even horizontal courses. That gives the walls their rhythmic, stable appearance. The fitting is what astounds. The stones lock together through their own geometry. The walls taper inward as they rise, a design that adds immense stability. This is Drystone walling elevated to an art form and a science. It required a deep inherited knowledge, a tradition passed down through generations of masons. They understood how to select the stone, how to shape it, and crucially, how to place it so each piece supported the next. But Great Zimbabwe was more than walls. It was a feat of urban planning. The city complex spread across nearly 2 square miles. It included areas for the elite, for artisans, for the wider community. The builders incorporated sophisticated drainage channels to manage the heavy seasonal rains that protected the foundations from erosion. The layout was strategic. It offered natural defenses, commanding views of the landscape, signaling both security and prestige. This level of sophistication forces a reevaluation. For a long time, Western scholars refused to believe an African civilization could have built it. They attributed it to outsiders. Archaeology has proven otherwise. Great Zimbabwe was the heart of a vast trading network. Artifacts found here include Chinese porcelain, Persian glass, Arab coins. This was a connected, wealthy kingdom. The stoneworking knowledge likely developed locally, refined over centuries. But it flourished because of this place in the world. The city was a hub, Ideas flowed here as well as goods. Great Zimbabwe stands as a powerful corrective. It challenges that linear narrative of technological progress, the one that places certain continents at the forefront and others as passive recipients. Here, in southern Africa, a civilization independently achieved a mastery of granite construction and urban design. It rivals any contemporary complex in the world. It speaks of autonomous innovation. A society that looked at the hard stone of its homeland and saw not an obstacle, but the fabric of its legacy. Their knowledge was carved not in scrolls, but in the enduring curving lines of these silent walls. And if such mastery could arise here, it makes you wonder about the many other centers of genius history has overlooked, whose stories are still waiting in the stone. Going down into, you feel the air get cooler. The light from above starts to disappear. You're not just going into a cave. You're walking through a hidden city. A city that was carved by hand, carved from the soft volcanic rock in Cappadocia. It's not a single tunnel, it's a vertical city. It goes down more than 200 feet. At least 18 levels have been found. It's a labyrinth built to protect an entire population, maybe 20,000 people, and their animals, their food, their places for worship. The size of it is hard to believe. The builders, they started in the Byzantine era, maybe even earlier. They didn't have dynamite, they didn't have powered drills. They had simple metal tools and a lot of patience. They carved rooms but also an entire infrastructure, stables for livestock, cellars for storage, communal kitchen, wineries and chapels too. This was a society that could function below ground for months, maybe for years. To remove that much rock by hand, the labor involved is staggering. It was a communal effort. It took generations. This wasn't a project born from ambition. It came from a deep, profound necessity. But the real genius is in the systems. A city this deep needs air, it needs water, it needs security, and the builders solved for all of it. There are over 50 ventilation shafts, some go all the way to the surface. They provided a constant flow of fresh air. These weren't random holes. They were placed carefully to use natural air currents, to prevent the deepest chambers from going stale. Separate wells tapped into the groundwater below. That gave them a fresh water supply independent from the surface. And for defense, they made the ultimate door. Massive circular stone slabs. These could be rolled across key passageways from the inside, sealing off entire sections of the city. They're like monolithic deadbolts. They weigh hundreds of pounds. They work on a simple lever system, which leads to the haunting question. What were they hiding from? The region's history has periods of intense conflict, of instability, was a refuge. Sanctuary carved from the earth itself. It's a survival strategy on a breathtaking scale. The community didn't just flee. They planned, they invested in a shared insurance policy, made of stone. The layout is in planning underground. Narrow, easily defended corridors connect wider communal spaces. The vertical design allowed for separation of functions and people. And the ventilation, the water systems, they turned a dark hole into a place you could live, is a monument to foresight. To a society that looked at the soft rock under their feet and saw safety. Not just building material, but safety. It's geotechnical engineering on a civic scale, a testament to what humans can do when the main motivation is collective preservation. It makes you think about the pressures that shape civilization. Sometimes, the greatest architectural wonders aren't the ones that reach for the sky. They're the ones that go down into the dark, to make sure a community can see another dawn. Edward moved a mountain of coral. He was a small man, a Latvian immigrant in Florida. He stood 5 feet tall, weighed 100 pounds. And over 28 years he carved and positioned over 1,100 tons of coral rock by himself. He called it Coral Castle. It's a modern echo of those ancient sites, a one-man megalithic place. The structures are bewildering. There's a 9-ton stone gate carved from one piece. It balances on a simple bearing so perfectly a child could push it open. It rotated freely for decades. There's a 23-ton obelisk, a 22-ton crescent moon block, a Polaris telescope, a stone rocking chair that weighs thousands of pounds, perfectly balanced stone spheres. All of it cut and shaped and moved by this one slight man. He worked almost exclusively at night. He kept his methods secret. When people asked how he did it, his answers were cryptic. He claimed he'd discovered the secrets of the pyramids. He spoke about the laws of weight and leverage and magnetism. He wrote pamphlets with simple titles, a book in every home, Magnetic Current. He wrote in a childlike script about his own theories of physics. He said he knew how the Egyptians built their monuments and that he was using the same principles. The practical puzzle is immense. How does one man with no modern machinery, no visible helpers, lift a 23-ton block onto a wall? The conventional explanation points to simple tools. There are photos of him with tripods made from old telephone poles, chains, winches. He likely used a system of block and tackle, leverage, ingenious counterweights. He may have moved the stones on rollers, pivoting them into place with immense patience. His genius might have been in applied mechanics, an intuitive understanding of pivots and fulcrums and balance, a way to multiply his own strength. But even that practical view strains under the weight of it. Some of his tools were rudimentary, makeshift. Witnesses reported seeing the heavy stones seemingly float through the air. Those accounts are anecdotal, but the precision is there. The perfect balance of that 9-ton gate, the seamless joints between stones, all achieved by a man with a 4th-grade education. It fuels deeper speculation. Did he find a forgotten application of magnetic resonance, harmonic vibration, a way to temporarily alter the weight of stone, an anti-gravity technique lost to time? Or was it, as he insisted, just a matter of knowing the right spot, the right angle, the right point of balance? Coral Castle is a powerful modern analog. It mirrors the Enigma of Puma or Baalbek, but with a known, recent creator. It forces the same questions onto a smaller stage. If one man in the 20th century could do this with claimed lost knowledge, then the feats of ancient cultures feel less impossible, more like a different application of the same, forgotten principles. His work challenges our assumptions about complex technology. It suggests that moving mountains might not be about raw power, but about a precise, secret understanding of the forces already in the world. His castle is a monument of stone, but also a monument to a possibility, that the greatest secrets of engineering might not be complicated. They might be profoundly, elegantly simple. And if that simplicity can produce these results, then every ancient site we look at seems less like a mystery of brute force, and more like a quiet conversation with the physics of the world itself. The silence in the caves is deep. It's a heavy quiet. You hear water dripping. You're in a space as big as a cathedral, but it wasn't built up. It was carved down. From the ceiling, these huge pillars come down, holding up the rock. The walls aren't rough. They're covered in marks. Uniform, parallel chisel marks, row after row, like a giant comb went over it. This isn't a natural cave. It's an excavated complex, a palace underground. No record of who built it, no record of why. The scale is hard to grasp. 24 caverns found so far, over 7 acres. Each cavern is immense, ceilings up to 100 feet high. The stone is a hard, red siltstone. To carve this out by hand meant removing over 1 million cubic meters of rock. That's a mountain of stone, taken out piece by piece, with simple iron tools. The logistics are staggering. The lighting, the ventilation, getting all that debris up to the surface, and the planning to keep it from collapsing while they work. That's where the precision is. The wall angles are consistent. The pillars are placed with clear intent. They support the vast ceiling. The chisel marks aren't random. They're uniform, parallel lines across huge surfaces. That means a standardized technique. A shared method for teams of workers. It points to a master plan. Someone had to design this before the first chisel hit. They had to understand the rock. They had to calculate where to put the pillars for support. This is architectural engineering in negative space. They weren't building a structure. They were carving the structure out of solid earth, and they had to get it right the first time. There was no room for error. One miscalculation could have brought 1 million tons of rock down. Then there's another detail. The design of some chambers seems to mirror surface structures. The pillar shapes, the layout of pools and channels. They echo above-ground palaces from that time. This wasn't a mine, it wasn't a quarry. It feels intentional, maybe ceremonial. A deliberate hidden mirror of the world above. But for what? A secret imperial retreat, a sacred space for rituals away from the sun, a colossal storage facility. No historical text from the era mentions it, not a single legend. A project of this magnitude, and it vanished from cultural memory. The caves are a riddle of motive. Why would a society commit generations of labor to something this difficult, this dangerous, only to leave it unmentioned, seemingly unused? It stands as a monument to forgotten engineering, a testament to what can be achieved and then lost. It whispers that our historical records are incomplete, that grand endeavors can sink beneath time, leaving only silent, empty shells behind. And it makes you think, if something this vast could be forgotten, what other wonders have been erased from our story completely? The Temple of Et isn't a building. It's a sculpture, A mountain of solid basalt carved from the top down. The architects didn't build it up. They carved it out. They removed 200,000 tons of rock over a century of work. They weren't making space for a temple. They were uncovering the temple they believed was already inside the stone. The result is a multi-story complex. A central shrine, pillars, life-sized elephants, courtyards, all one single piece of the original cliff. The planning is hard to grasp. This was subtractive architecture. Every chisel strike was permanent, no adding material back, no fixing a major flaw. The master architect had to hold the entire final form in their mind. They had to tell teams where to cut and where to stop. They had to leave the pillars, the staircases, the roof towers as the excess rock was hauled away. A three-dimensional blueprint executed in reverse. The labor coordination was a symphony. Thousands of workers over generations, a choreographed sequence. At the top, cutting trenches to define the outer walls. Sculptors following, carving deities and scenes. Others removing the rubble, maybe with ramps and pulleys. The noise, the dust, the effort overwhelming. But the product is serene order, profound spiritual power dedicated to Shiva. Their tools were simple, iron chisels and hammers, yet the detail defies belief. The surface is a tapestry, delicate lotus patterns on the ceilings, gods and goddesses in graceful poses, expressions still vivid after 1,200 years. They shape the hard basalt with a fluency that suggests a deep dialogue with the material. They understood its grain, its weakness and strength. Redefines creation. The builders didn't impose a form on the landscape. They engaged in discovery, liberating a sacred space they believed was already present. It's the convergence of devotion and engineering. Faith provided the vision. Mastery of stone, physics, and immense patience provided the method. The most audacious rock-cut structure on Earth. The greatest act of construction isn't about what you add. It's about what you have the vision and courage to remove. They didn't only carve mountains. They moved them. The temples on Gozo are older than the oldest pyramid. They're the oldest freestanding stone structures we have. These walls rise from the ground, built from massive blocks of coralline limestone. They were already ancient when the builders of Stonehenge were just starting. This is a Neolithic achievement from around 3600 BCE, a time we think of as simple, the age of early farmers. And yet these farmers built a temple complex that's lasted 5,500 years. The scale is humbling. The South Temple walls still stand over 20 feet high in places. The blocks are colossal, some weigh over 50 tons, and they had no metal tools to shape them, no wheels to move them, no pulleys to lift them. This was a society working at the very dawn of monumental architecture. They were inventing the rules as they went. Just the transportation is a profound puzzle. The limestone was locally, but that still meant moving these megaliths across rough ground. The most likely method was a symphony of communal effort. Hundreds of people, ropes made from plant fibers. They would have placed log rollers underneath. They used leverage. They used the slope of the land. They used a deep, intuitive understanding of physics passed down not in writing but through practice. A slow, rhythmic dance of stone and human determination. Once the stones arrived, the assembly began. The architecture shows a leap in thinking. The temples are built in a cloverleaf plan, a series of curved, interconnected chambers. To create these enclosed spaces, they used corbelling. They would lay each course of stone slightly inward from the one below. Gradually, over many layers, the walls would curve toward the center, forming a domed ceiling. This is early architectural engineering. It required planning, an understanding of load and counterbalance. Each stone had to be placed just so, to support the weight above and create a stable, sacred space inside. In these spaces, archaeologists have found altars, curious stone slabs with circular depressions. Some researchers think these weren't just for offerings. They may have been aligned. They could have functioned as simple astronomical markers, tracking the sun or moon for a society tied to the cycles of planting and harvest, which suggests the temples were more than ritual centers. They were perhaps calendars in stone, interfaces between the community and the cosmos. So what drove these early farmers to do this? They had no king, no pharaoh to command them. This was likely a collective act, a society that channeled its surplus energy, its deepest beliefs, into creating a permanent home for the sacred. The construction itself may have been the ritual, the act of moving the giant stones of, which means Giant's Tower may have been woven into their mythology. A story of ancestral giants that gave meaning to their own colossal labor. The techniques were passed down through generations, master builders teaching apprentices, a living tradition of stone knowledge that flourished and then vanished from these islands. The temples are a cornerstone. They prove that the drive to build monumentally, to reach for permanence through engineering, isn't a product of advanced empires. It's a fundamental human impulse. It emerged among some of the earliest farming communities we know. They looked at the landscape and saw not just fields to till, but stones to raise. They left a question echoing across the, how does a society with so-called simple technology achieve such complex, enduring results? The answer is in the silent, sun-warmed limestone. It speaks of organization, of shared purpose, and of a knowledge so deeply understood it needed no written manual, only hands and time and stone. The ocean keeps its secrets. Off the coast of Island at the edge of Japan, the seafloor just drops away into this formation. It looks like a city, massive flat terraces stacked like a staircase for giants, with sharp right angles, straight walls going straight down. You see what look like wide steps and platforms and even these carved pillars, all of it sitting under about 80 feet of water. That's the monument. A diver found it in the 80s and it's been argued about ever since. The rock is sandstone. Sandstone can fracture in straight lines. It can be shaped by tidal currents over thousands of years. A lot of geologists see that, a stunning natural formation, from seismic activity and erosion. They point to the coast, above water, where the rock has the same sharp, angular breaks. Nature can sculpt. But then you look closer, and some features make you stop. Two huge cylindrical pillars side by side, a narrow trench that runs straight for dozens of feet, a triangular depression that seems carved, a face, some say, like a crude. The strongest argument isn't one detail, it's the accumulation. The sheer concentration of what looks like architecture all in one spot. If it's natural, it's a masterpiece of coincidence. If it's artificial, it changes everything. The scale would be immense. Shaping these monoliths, some over 150 feet long, would need a society with advanced stonework and boats, and the timeline is the staggering part. Based on sea level rise, this would have been above ground on dry land around 10,000 years ago. That date is profound. It's thousands of years before the pyramids, before most ancient wonders. It pushes monumental construction back into deep prehistory. The implications ripple out. It suggests a lost Pacific civilization, a culture that lived on what's now the continental shelf, then was swallowed by rising seas as the glaciers melted. Great flood myths exist everywhere. Could be an anchor for one of those stories, a stone proof of a world that vanished. The debate is a lesson in how we see the past. How do you tell nature's incredible work from the intentional human hand? It forces archaeologists and geologists to refine their tools, to look for the subtle marks of tools, for repetitive patterns erosion doesn't make, for quarrying logic, stays in a gray zone, a captivating frontier, a mystery that resists being solved, hidden by the water that preserves it. To dive there is to hover in uncertainty. You're either looking at one of geology's greatest tricks or you're floating above the drowned rooftops of a forgotten world. Either possibility is humbling. It reminds you the Earth is an archive, and some of its oldest pages are underwater waiting to be read. There are 3,000 stones at Karnak, standing in rows, long straight lines that go on for miles. They've been there for a very long time, since the Neolithic, since farmers first started putting them up, maybe 6,500 years ago. And they kept doing it for centuries, maybe 1,000 years, just stone after stone after stone. The number is what gets you first. It's so many that it becomes something else. It makes you ask how they did it, how they kept doing it. They didn't have metal. Their tools were stone, wood, bone. To get the granite blocks out, they probably used fire. Heat the rock, then pour water on it to crack it. Then work it free with stone hammers. Then they had to move them. The granite came from miles away. No wheels, no animals to pull them. So it was people, ropes, logs to roll them on, teams pulling these huge stones across the land, a slow procession that probably happened every year. And then they had to stand them up. Dig a hole, tilt the stone in, use levers, pack the earth around it, a simple process. But they did it 3,000 times. But the real achievement isn't one stone, it's the pattern. The rows are parallel over that whole distance. To do that, they had to survey the land. They used sight lines, features on the horizon, maybe simple wooden levels. They engineered the whole landscape, made it into a ritual space. So what was it for? The stones don't say. Some think it was about the sky. Some rows line up with the sun at the solstices, a giant calendar for farming. Others think it was ceremonial, a path for rituals, for connecting with spirits in the stones, or it was a territory marker, a statement in granite. We are here. The answer is probably all of it. A sacred landscape for astronomy, ceremony, memory. The knowledge to build it wasn't written. It was lived, passed down by doing it, from one generation to the next during the work itself. The work was the ritual. Doing it for centuries is what held them together, linked them to the ancestors who started it and the ones who would come after. When you walk there now, you feel that. It's not a monument to one person, it's a collective will. It shows that long before empires, people could make plans that lasted lifetimes. They could carve their beliefs into the earth, so quiet but so overwhelming, that the question it asks, it's still there. After 6,000 years, the Avenue of the Dead runs straight. It points to a mountain shaped by human hands. This place is, the later Aztecs, they named it that. They called it the place where men became gods, but the people who built it, they left no name for themselves. Their language is silent. But the city speaks. It speaks in stone and earth. It's a master-planned metropolis, a grid of precision laid out in the Valley of Mexico over 2,000 years ago. At its heart is the Pyramid of the Sun. It's not the tallest pyramid, but its presence is overwhelming. It contains over 2 million tons of material. Adobe, brick, rubble, earth. And the builders, they didn't just pile it on flat ground. They built it over a natural cave, a sacred portal into the earth. They integrated the landscape into their cosmology. The alignment is the first clue. The pyramid's western face points directly to the setting sun on specific days, and the entire city grid, it's oriented just slightly east of true north. This wasn't an accident. It was a deliberate citywide alignment, tied to celestial events, likely tied to the agricultural calendar, their understanding of cosmic order. Walking the grid, you see the engineering in the empty spaces, the drainage. A city of over 100,000 people needs water. It needs to manage the fierce seasonal rains. They built an intricate network, canals and underground drains. They channeled water from nearby springs, distributed it through the city, prevented catastrophic flooding. This is hydraulic engineering on a civic scale, the unseen skeleton that allowed the city to thrive. Then there's the architecture itself. The dominant style is called, you see it on the Pyramid of the Feathered Serpent. On platforms throughout the city, it's a series of alternating slopes and vertical panels. The is the sloping base. The is the upright framed panel on top. It looks simple, but its construction required precise angles, consistent proportions. To maintain stability and visual harmony across vast structures, it's a signature. A standardized architectural language. It screams of central planning, shared technical knowledge, and then you hear it in certain places. On the steps of the pyramids in the plaza, a hand clap, a spoken word, produces a strange, distorted echo. It's an acoustic phenomenon. Some researchers suggest the staircases and platforms were designed to create these effects, intentionally or not. Could they have understood sound reflection? Were these spots meant to amplify a priest's voice, to create an otherworldly auditory experience during ceremonies? It's another layer of mystery in a city built by unknowns. Which circles back to the central question. How did an anonymous civilization achieve this? We cannot even name them. They had no iron tools, no wheels, no beasts of burden. Their construction was a symphony of human labor. Levers, ropes, log rollers, yet they executed a vision of staggering complexity. They moved mountains of material. They engineered for water, for permanence, for celestial alignment. They built a city so perfect that later cultures believed it was the birthplace of the gods. Stands as a testament to a different kind of legacy, not of kings and conquests recorded in stone, but of collective, anonymous genius. It proves a society can reach breathtaking heights, of engineering, of urban design, without leaving a single name behind. Their monument is the plan itself, a silent geometric prayer to order, written across the land in avenues, in pyramids, in the flow of water. The stone in Malta, this Globigerina limestone, it feels warm. It holds the sun's heat. And on that island 5,000 years ago, builders used it. They used it to shape their world. The temples there, Hagar, and they aren't just buildings. They're calendars, observatories cut right from the rock, built by a culture that left no writing, just these silent machines made of stone. The architecture has a soft geometry. Massive slabs, some over 20 tons, arranged in these cloverleaf plans. They create curved chambers, apses, all linked by narrow passages. But the real marvel is in the doorways and the altars. They weren't built from pieces. They were carved from single blocks. A sculptor would look at a monolith and see a doorway inside it, then remove everything that wasn't the doorway. The result is a seamless threshold. An altar that emerges from the floor as one continuous piece with the temple. It's subtractive architecture. It demanded a complete vision before the first chip of stone was struck. Their choice of stone was a blessing and a challenge. Globigerina limestone is soft when easier to carve than granite. It allowed for intricate spiral patterns, those pitted decorations you still see on some slabs, but its softness meant it weathered. It eroded over under the sun and the salt wind. The very thing that made it workable also made it vulnerable. And then there was the transport. Moving these multi-ton slabs from quarry to temple site across rocky terrain without the wheel or metal tools. It speaks to a society that had perfected megalithic logistics, a communal effort repeated over generations. Yet the most breathtaking precision isn't in the carving, it's in the alignment. These temples are locked to the sky. At the lower temple is a piece of solar engineering. On the spring and autumn equinoxes, the first rays of the rising sun cut directly through the main doorway. They travel down a central corridor to illuminate the innermost altar stone. The light paints a perfect rectangle of gold on that slab, an event that happens just 2 days a year. A moment of perfect alignment engineered 5 ago. At Hagar, the effect is more subtle but just as intentional. Specific apertures, holes carved through the megaliths, seem designed to channel sunlight on the solstices. A beam of light penetrates the dark interior, marking the longest and shortest days with a silent, predictable spotlight. Achieving this required more than marking a sunrise. It required generations of observation, a deep, accumulated knowledge of the solar cycle. It required the architectural skill to translate that celestial rhythm into fixed stone, orienting an entire massive structure within a fraction of a degree. This fusion of cosmology and construction forces a question. What belief system was so powerful it compelled them to encode the heavens in limestone? They were farmers, fishermen. Their lives depended on the seasons, on the predictable return of the sun for planting and harvest. The temple was the interface, the mechanism that confirmed the cosmic order, that reassured the community the cycle would continue. By building a machine that captured the sun's light on the pivotal days, they made the intangible tangible. They gave physical, architectural proof to their faith in the universe's rhythm. These Maltese temples are among our earliest attempts to literally build a connection between earth and sky. They represent a leap in thought, from observing the stars to constructing a permanent, unmovable instrument to measure their dance. It's a testament to a forgotten people who looked at a soft block of stone and saw not just a building material, but a canvas for the cosmos. Their legacy is a silent alarm clock, set by the ancients, that still rings with the light of the sun. Descending into the is like entering a different Egypt. Up above is the temple of Seti I. It's covered in hieroglyphs in painted reliefs. It tells stories. But then you walk a short distance and you go down a set of stairs, down into the earth, into a space of silence and mass. The walls here are made of enormous blocks, red granite. They're colossal and rough-hewn. There's no decoration, no color, just the weight of the stone. It feels ancient in a way that doesn't match its official date. This structure is an anomaly, a ghost from a deeper past. The layout is unique. There's a central hall built like an island, and around it a deep channel cut from the living rock. That channel was designed to hold water. It creates a moat. They found evidence it connected to the groundwater. So this was a managed, symbolic body of water built right into the foundation. The engineering challenge was significant. They were building below the water table in an area that floods. The structure had to withstand hydraulic pressure, the constant push of groundwater. Those massive, interlocking blocks were the solution. Their weight and their precise fitting created a stable chamber in a saturated environment. But the stonework whispers of another time. The blocks are megalithic, some weigh over 100 tons. They're fitted with that breathtaking precision. The joints are tight, the surfaces are flat. This is Cyclopean masonry. It looks nothing like the smaller limestone blocks of Seti's temple above. It looks instead like the core masonry at the Valley Temple at Giza, which is thousands of years older. The contrast is jarring. It's like two different cultures, separated by vast time, built on the same ground. That's the core of the mystery. Conventional history says the is a cenotaph, a symbolic tomb for Osiris built by Seti or his son. But why would these pharaohs, masters of decoration, build in this stark, archaic style? And why bury it? Some researchers point to the weathering. The geologist Robert suggested the structure shows signs of water erosion from heavy rainfall, a climate Egypt hasn't had since the end of the last ice age, long before the first pharaohs. This theory is debated, but it adds a layer. It suggests the foundations might be pre-dynastic, a relic from a forgotten epoch, later discovered by the Egyptians of Seti's time. They recognized its antiquity. They built their temple to align with it, to tap into its power. So what was its original purpose? The island surrounded by water is a powerful symbol. It mirrors the Egyptian creation myth, the first land emerging from the primordial waters. This structure could be a physical representation of that myth, a place of first creation, a temple dedicated to the act of Genesis itself, a machine for ritual, where priests could reenact the moment the world began, standing on that primeval mound within the encircling waters. There is a quiet subterranean challenge to the timeline. It hints that the sands hold memories older than the dynasties. It suggests the engineers of the Pyramid Age may not have been inventors but inheritors, students of a lost school of stone. This place doesn't just honor a god, it guards a secret about who was here first and what they knew about building forever. These spheres, they look like they came from a dream, found in the delta in Costa, over 300 of them. Some are small, you could hold one. Others are huge, over 2 meters wide, weighing 15 tons. They're carved from gabbro, that's a hard volcanic rock, and from limestone and sandstone. The surfaces are incredibly smooth. The shape is a near-perfect sphere. This isn't natural, it's geometry made solid, made by the culture starting around 600 CE. They left no writing, just these silent, flawless orbs. That precision is the first clue. Making a true sphere from hard stone at that scale is a profound challenge. Any error in symmetry, you'd see it, you'd feel it. The larger ones have been measured. Their sphericity is within a tiny margin, and the consistency across hundreds of them points to a standardized technique, a shared method. They weren't guessing. They knew how to make this form again and again. So how did they do it? Without metal tools, without powered lathes. The process probably started with choosing a boulder. Then rough shaping, using stone hammers to peck away the excess. But the final stages, the smoothing into perfect roundness, that's where it gets mysterious. Researchers think it was a multi-step method. They might have used heating and cooling, building a fire around the stone, then cooling it fast with water, to create controlled fractures, making the stone easier to work. Then the final polishing. That could have involved grinding the sphere with sand, using abrasives, maybe while it was rotated or rolled in a cradle of other stones. It was a slow, patient dialogue with the material, a testament to an empirical understanding of fracture, of abrasion. But the stones weren't meant to be seen alone. Their arrangement tells another story. Many were found in groups, in lines, in triangles, alignments that pointed toward chiefs' houses or toward significant hills or to celestial events. They were placed with intention. That transforms them. From sculptures into a language, a physical language of alignment and meaning. They could have been territorial markers denoting important spaces. They could have been symbols of power, their size and perfection reflecting a lineage's status. And most compelling, their alignments suggest a cosmological function. They may have been a permanent stone calendar, mapping the movements of the sun or stars, anchoring the worldview to the land they lived on. The spheres are a convergence of art, science, and social order. Making them required a deep, practical knowledge of geometry and material science. Placing them required an understanding of landscape and astronomy, and valuing them required a shared cultural belief to make this immense effort meaningful. Then, around the time of European contact, the culture faded. Their sites were abandoned. The spheres were swallowed by the jungle. Many rolled into ravines or rivers by later people who didn't know their purpose. Now, they're a global icon of lost precision, a reminder that a society can master a complex craft, encode their knowledge in the physical world, and still vanish, leaving only their most durable questions behind. We can measure their perfection, but we can only wonder at the minds that conceived it. If a culture could render the most perfect shape from unyielding stone, what other forms of knowledge just as precise were lost when their world changed? Is a stepwell in Rajasthan. It's an inverted pyramid carved into the earth, a symmetrical void. It was built in the 9th century, 13 stories down, over 3,500 steps. They descend in a perfect, repeating pattern. On three sides, the staircases create this visual cascade, a precise fractal, leading to a deep, dark pool of water at the bottom. This isn't a hidden structure, it's an open declaration. A monument built not to a king or a god, but to a necessity: water. In the arid landscape of Rajasthan, water was life, it was power, it was community survival. The stepwell is a masterpiece of hydrological engineering. Its design is a cooling system. The massive, deep pit creates a temperature difference. The air at the bottom, near the water, is much cooler than the surface air. That made it a refuge from the desert heat. But its genius is in water conservation. The vast tiered structure maximized surface area for collection. During the monsoon rains, water would cascade down the steps, channeled into the central reservoir. The depth minimized evaporation under the sun. Every aspect of its form served that function. The stability of the structure is a quiet marvel. It was built from local stone, fitted together without mortar. That precise Drystone construction allowed for flexibility. In a region prone to seismic activity, a rigid mortared structure might crack, but interlocking stones could shift slightly. They could settle, absorb movement without failing. The staggering weight of the stone, combined with its geometric layout, created a stable equilibrium. Against the pressures of the earth, it was engineered to last, yet it was always more than a reservoir. The fourth side of the square is a vertical wall, adorned with pavilions, carved balconies, rooms cut right into the rock face. This was a social space, a community center, where people gathered not just to draw water but to rest, to converse, to perform rituals. The stepwell fused the practical with the artistic. The rhythmic steps are both a functional path and a visual pattern. It represents a philosophy where necessity didn't limit beauty. Necessity inspired it, asks us to reconsider infrastructure. Here, a public utility was elevated to sacred geometry. It reflects a society that understood its environment intimately. The scarcity of water, the intensity of the heat, the instability of the ground, and it responded not with a mere tool but with a timeless communal work of art. It stands as a testament to a different kind of ambition, not to reach for the heavens but to master the depths, to harness an element. And in doing so, to create a space that nourished both the body and the spirit. For over 1,000 years, the spheres of Costa measure perfection in stone, but the first monumental architecture might not have been about perfection. It was about a message, carved into a hilltop at the very beginning. The stones aren't spheres, they're giants. Massive limestone pillars shaped like the letter T, some stand over 18 feet tall. They weigh 20 tons. They were raised over 11,000 years ago. That's 7,000 years before the pyramids, 6,000 years before Stonehenge. The people who built this weren't farmers. They were hunters and gatherers. They had no metal, no wheels, no permanent villages we know of, and yet they carved these megaliths from the bedrock. They moved them. They stood them in great stone circles. This one site shatters a belief. The belief that complex society, that monumental architecture, required agriculture, required cities and kings, suggests the opposite. It suggests the drive to build something immense and sacred might be what brought people together first. What compelled that cooperation? The pillars hold clues. They aren't blank, they're covered in art, a menagerie of the ancient world. Foxes, cranes, scorpions, lions. These aren't random scratches, they're intricate reliefs, deeply carved into hard limestone. This was a symbolic language, a shared belief system powerful enough to motivate the work. The logistics are staggering. Quarrying a 20-ton pillar from the local limestone, using only stone tools, then transporting it, likely with ropes and log rollers with hundreds of people coordinating the pull, then digging a pit, levering the pillar upright, and finally arranging multiple pillars into precise circles, often with two even larger central pillars. Speaks of a project manager, a master architect of the Neolithic, someone who could envision the final ring and direct teams to make it real. The social organization required is profound. It means these hunter-gatherers had roles, they had schedules, they had a way to feed a large workforce, maybe gathering seasonally for the construction. They weren't simple nomads. They were a society capable of long-term collective projects, a society that invested generations into a spiritual center. The most haunting question is why they buried it. After centuries of use, they deliberately filled the great stone circles with rubble. thousands of tons of soil and stone carefully laid in, preserving the site for until its rediscovery. Was it a ceremonial closing, a way to retire a sacred space with honor? That act of intentional burial is as calculated as the construction. It shows a reverence for the place that transcends its physical use. Stands as a silent revolution. It pushes the timeline of human achievement back into a misty, pre-agricultural past. It suggests the temple came before the town, that the need to create a shared sacred space to carve our understanding of the world into stone might be the very spark that ignited civilization, not as a result of surplus, but as a cause for coming together. If this is where monumental building truly begins, then everything after, the pyramids, the temples, the walls, feels less like a sudden invention, more like the continuation of an old human conversation. One that started with hunters, gatherers, and a hilltop covered in stone giants. The cliff face was the canvas. At end, they didn't build, they revealed. For centuries, they carved directly into the basalt of the plateau, peeling back layers of stone to uncover entire worlds inside. It was architecture in reverse, a process of subtraction where every strike of the chisel had to be perfect. You couldn't add material back. Caves started in the 2nd century BCE, their monastic retreats hidden in a horseshoe-shaped gorge. The challenge was profound. Teams began at the top of a cliff section. They'd cut a narrow tunnel in, establishing the ceiling height. Then they worked downward and outward, excavating the vast interior space, all while leaving behind the structural elements, the pillars, the stupas, the arched ceilings, as part of the living rock. One mistake in sequence, one misjudgment of load, and the ceiling could collapse. The precision is in the proportions. The prayer halls, with vaulted roofs and rows of pillars that aren't built but freed. But isn't just architecture, it's a painted manuscript. The walls and ceilings are covered in frescoes, scenes from the life of the Buddha, courtly life narratives that have survived 2,000 years. Creating these required solving other problems. They needed light, so they carved large horseshoe-shaped windows into the facade. These funneled sunlight deep into the cave, illuminating the art without direct, damaging rays. They needed a smooth surface. So they developed a complex plaster, using clay, dung, rice husks applied to the rough rock. Only then could the mineral pigments be applied. Only then could the stories be told. Centuries later, miles away, took this tradition to its zenith. The ambition was grander. 34 caves representing Buddhism, Hinduism, and Jainism carved side by side in a single basalt cliff. A timeline of faith written in stone. The most staggering is Cave 16, the temple. A mountain turned into a temple, but the other caves show the same relentless engineering. Multi-story monasteries were excavated, with living quarters, kitchens, meditation cells, all flowing from the solid rock. Drainage systems cut into the floors. Ventilation shafts planned for deep, windowless chambers. What unified this work across 1,000 years? It was more than devotion. It was a pursuit of permanence, of purity. By carving a sacred space directly from the earth, it became part of the eternal landscape. It couldn't burn. It couldn't be easily defiled. The act of creation was an act of merit, a meditation in physical form. The transfer of plans into stone likely began with sketches on the cliff face. Master architects marked the proportions. Then the subtraction began, a slow, dangerous dialogue between human intention and the character of the stone. These caves stand as a testament to a different kind of wealth, not of gold but of time, of collective will. Generations of artisans dedicating their lives to a vision they'd never see completed. They are shelters for the spirit, engineered with an understanding of rock, light, and space. In their cool, silent halls, you walk through an idea made solid, the belief that the sacred could be found not by building up, but by carving inward, to reveal the sanctuary waiting inside the mountain all along. Mohenjo-Daro, the streets run straight. They meet at right angles. It's a grid. A city planned out over 4,000 years ago. One of the first. They didn't build randomly. They built with intention. The scale is huge. Maybe 40,000 people lived there. And every brick, every lane follows a plan. You see it in the bricks. They're not random sizes. They have a consistent ratio. The same proportions repeated. That wasn't just convenient, it was revolutionary. Any brick from any kiln could fit any building. It allowed for mass production, a modular way of building. The whole city shares a technical language, a language of measurement. That order is in the layout. The main roads are wide, some over 30 feet. They divide the city into blocks. Smaller lanes branch off to homes. This grid did more than look neat. It managed flow, movement of people and goods, and it provided access for water. Beneath the streets is another city, a hidden system. Almost every house had its own bathing area, a brick-lined platform with a drain, but these private drains didn't just go to the street. They connected to a covered sewer system. Brick-lined channels under the lanes, covered with stone slabs you could lift. They sloped gently using gravity to carry away. This was a public health system in baked clay, a conscious effort to separate clean from unclean, to manage urban life on a massive scale. At the center is the Great Bath, a large rectangular tank lined with bricks. The engineering is in the seal. They used a layer of natural bitumen, a tar-like substance between the brick walls and an inner lining that made it waterproof, fed by a well with a drain for emptying. It wasn't just a pool. It was a public facility, probably for ritual. It shows a masterful control of water, containing it, sealing it, managing its flow. This planning implies a social organization. There's no obvious giant palace, no monumental tomb for one ruler. The city's grandeur is in its utilities, in the access to sanitation and water. The investment was in the communal. It suggests a society governed by a shared ideal of civic order, maybe by engineer priests, or a strong administration that could enforce building codes for centuries. Which makes its disappearance sharper. The Indus Valley civilization faded. Its cities were abandoned. Its script is still unread. Its innovations, the grid, the standard bricks, the covered drains, they seem to vanish from the record. Later, great cities in ancient India followed different patterns, more organic, centered on temples or forts. Why wasn't this model continued? Did the knowledge disappear with the civilization? Was it too dependent on a centralized authority that collapsed? Or did later cultures choose different values, prioritizing other expressions of power over this utilitarian uniformity? Mohenjo-Daro stands alone, a proof that a different path was possible and achieved, a model where urban brilliance was measured not in monuments but in the efficiency beneath the streets, a model of foresight. It makes you wonder about the roads not taken, the air in the is still. Cool, you hear your own breath. You're walking down a long tunnel cut right into the rock, and on both sides set into the walls are the boxes, 24 of them. Each one is a single block, granite or diorite. A stone so hard it fights ordinary tools. Each box weighs about 70 tons. The lid is separate, another 30 tons. They're polished, not just smooth, a mirror finish. In torchlight you see your reflection in stone shaped 2,000 years ago. The scale is one thing, the precision is something else. The inside corners are sharp, perfect right angle. The surfaces are flat, unnaturally flat, like they were machined. This isn't rough stonework. It's precision engineering buried in a maze. The first puzzle is the stone itself. Granite this hard. To shape it, to get those flat planes and sharp corners, you need more than a chisel. Egyptologists talk about a method with abrasives. A slurry of quartz, sand, and water pumped under pressure with a saw, maybe a copper blade, could cut granite. For drilling, a tubular drill with the same abrasive paste could hollow out space. But the process is slow, achingly slow. It needs constant pressure, constant new abrasive. To do this on 70 tons of stone for 24 boxes represents an investment of time and labor that's almost impossible to grasp. It means a society with immense resources and a singular, unwavering focus on one specific form. Then comes the second puzzle, maybe the greater one, the logistics. These boxes were at Aswan, over 500 miles to the south. Moving a 70-ton granite block by river barge is a feat by itself, but at Saqqara the challenge grew. The boxes had to be brought to the site, then lowered down a deep shaft or moved down a sloping tunnel. Then in these narrow, confined underground passages, they had to be slid into their exact niches. The clearance between the box and the tunnel wall is tiny. No room for error, no space for big teams or complex machines. How did they do it? The most plausible theories involve counterweights, levers, lubricated pathways. They might have built temporary ramps of sand, lowered the sarcophagus slowly into place, then removed the sand to leave it sitting on the niche floor. It's a silent ballet of physics done in near-total darkness. But what were they for? The is for the Apis bull, a living embodiment of the god Ptah. When a sacred bull died, it was mummified with elaborate ceremony. These colossal stone boxes are sarcophagi, made to hold the remains of these animals. The choice of material, the staggering effort, it tells you something. This wasn't just burial, it was an act of eternal preservation. Granite was chosen because it was the most durable thing they knew. By sealing the apis in this imperishable stone, they were making sure its divine essence lasted forever. The precision of the boxes might have had a ritual purpose, too, a perfect, sealed environment for the journey to the afterlife. This is a dark, polished monument to a very specific ambition. It's not about reaching for the sky. It's about securing something for eternity deep in the earth. It shows a mastery of material and logistics that rivals the pyramid builders, but applied with a quiet, focused intensity. In this silent corridor, you're not faced with a towering monument. You're faced with a contained, perfect form. A 70-ton question, polished to a shine, waiting in the dark. It shows that advanced engineering isn't always about what's grand and visible. Sometimes it's about what's hidden, heavy, and made to last forever. And if they could do this with stone, what other capabilities, now lost to time, were once just routine? The story of Baalbek goes beyond those 3 stones. It's the whole platform. The Romans put their temple of Jupiter on a foundation that was already ancient, and that foundation is made of stones that shouldn't be possible. Under the Roman columns, there's an older layer, a Cyclopean platform. The stones here are even bigger than they're fitted together with that same precision. No mortar, just geometry and weight. These megaliths have lasted they're in an earthquake zone. They've weathered all of them. That survival isn't luck, it's the engineering. The way they interlock, the way they distribute force, it creates a stability that rigid construction doesn't have. This platform was made to move with the earth, not fight it. Then there's the leveling. The platform covers acres, and it's remarkably flat. To get that over such an area with stones this size required advanced surveying, water levels, sighting instruments to create a true horizontal plane. This isn't rough work, it's exact. The orientation seems deliberate too, aligned to something celestial or geographical we don't see anymore. That level of planning means a master blueprint, a long-term vision, and then the stones had to get there. The quarry for these foundation blocks is almost a mile away. So a civilization long before Rome, stones weighing hundreds of tons, they shaped them, then moved them a mile over uneven ground, and lifted them into place to form this base. The logistics are staggering. The labor, the physics, the will, it points to a society of extraordinary capability, which forces the question, who were these builders? The Romans found this platform and built on it, as if acknowledging a legacy they couldn't match. The masonry style is Roman. It's older, more massive. Some look to the Bronze Age. To the Canaanites who held this land as sacred long before Rome, could they have had a lost school of engineering, a knowledge that let them work on a scale that inspired myth? The platform is a historical palimpsest, a layer cake. The Romans wrote their chapter on top, but beneath it, in the language of gigantic stone, is an older text. It tells of people who looked at a hill and saw a project for the ages. They began a work so solid, so perfectly conceived, that later empires had to build on it. Their names are gone, their reasons are silent, but their handiwork is there, an immovable question set into the foundation. The capstone weighs 180 tons, a slab of limestone, it could crush a house, and they lifted it into the air. This was a Neolithic community, the Dolmen in Spain. It's a passage grave, built by early farmers, around 3700 BCE. They shaped the landscape into a monument for the ones who came before. The structure looks simple, a long sloping corridor. It leads into a wide chamber. The walls are massive upright stones, each one chosen and set, and spanning the top, resting on them, is that single capstone. The challenge is the size, but also the distance. The limestone came from a mountain, several kilometers away. To move it, they had no wheels, no metal, no beasts of burden. Their tools were wooden levers. Ropes of plant fiber, the collective strength of hundreds. The method was patience and physics. They probably built a temporary road of logs, lubricated with water or clay. Teams would pull with ropes, inching the stone forward for days, for weeks. To lift it, they likely built an earthen ramp against one side of the chamber. They would drag the capstone up this slope, using counterweights and leverage, until it slid into its final position. Every step required a shared blueprint. Flawless coordination, a communal project that defined a generation, a testament to their unity. But the genius goes beyond the stone. The builders looked to the horizon. The central axis of the corridor is aligned, precisely aligned, with a mountain peak. La Lo's, this was deliberate, a choice to integrate architecture with a sacred natural feature. On the summer solstice, the rising sun would shine directly down the corridor, illuminating the inner chamber, a dramatic display of light. This fusion of tomb and landscape suggests a cosmology where the ancestors weren't separated from the world. They were connected to its cycles, the sun, the earth, the prominent hills. What does this show about the society? A project this scale implies organization, not a hierarchy of kings, likely a theocratic or clan-based structure, where spiritual leaders could mobilize labor for a common sacred purpose. The effort itself may have been a ritual, binding the community together. The dolmen was more than a tomb. It was an anchor of identity, a permanent house for the ancestors, that also served as an astronomical marker, linking life, death, and rebirth to the turn of the seasons. The dolmen is one of Europe's profound megalithic achievements. It whispers that 5,000 years ago a farming community looked at a mountain, then looked at a quarry, and saw a connection. They moved a mountain of stone to build a bridge between the living, the departed, and the cosmos. Their legacy isn't written, it's raised. A quiet dialogue between human ambition and the ancient earth. The road is stone, a ribbon laid across the roof of the world. It clings to cliffs, it drops into valleys. It goes over passes so high the air is thin. That's the Inca road system. And it wasn't just one path, it was a network, a web for communication and control stretching 25,000 miles. From the coastal deserts up through the cloud forests to the icy Andean peaks. The Inca built an empire in a vertical world, and this road was the nervous system. The lifeline. Building it was defiance. They had no wheels, no iron tools. Their world was slopes, tremors, torrential rain, but they engineered a solution for every obstacle. Where the ground was soft or marshy, they paved it with flat stones, a surface that drained water. On steep mountainsides, they carved stairways right into the rock, long flights of steps that made the impossible slope navigable. They built retaining walls to hold back landslides. They cut drainage channels alongside the paths to stop erosion from the heavy rains. Every feature answered the challenge of the place. Then there were the bridges. Over deep ravines and rushing rivers, they built suspension bridges, but not with steel or concrete, with grass. Teams would braid grass into massive cables, thick as a person's torso. These cables were anchored to stone abutments on either side of a chasm, planks laid across for a walkway. Handrails of smaller cables strung alongside. These fiber bridges weren't permanent, they were living infrastructure. Communities maintained them, renewed them in a yearly ritual, weaving old knowledge and new materials together, engineering as a communal duty, a partnership with the material. The system's intelligence went beyond the path. At regular intervals they built tambos, storehouses, barracks, shelters. A runner could sprint from one tambo to the next, relaying a message across the empire in days, not weeks. Officials and armies traveled with the support of these stock depots. That logistical planning turned a vast, fractured geography into something unified, manageable. The road moved more than feet. It moved information, authority, goods with speed. The route selection shows a deep understanding of the land. Inca engineers didn't take the shortest line. They took the most sustainable one. The path often traces contour lines, minimizing steep grades for people and llama caravans. It avoided floodplains, unstable slopes. The road flows with the topography, it doesn't fight it. That respect for the terrain might be its greatest lesson. It was built to last, not to conquer. How did they plan it without written blueprints, without modern tools? The knowledge was in tradition, observation. They likely used sighting lines between high peaks, clay models to plan routes. Construction was state-sponsored. Labor mobilized through the system, where communities contributed work as a tax. A collective project on a continental scale. This stands as a monument to a different kind of power, not power to dominate nature, power to listen to it, to integrate human need with environmental reality. It shows advanced infrastructure isn't about the complexity of the tools, it's about the intelligence of the adaptation. Now when we grapple with the environmental cost of our own networks, these ancient stone paths and grass bridges ask a quiet question. What does it mean to build a system that serves an empire, yet is woven so gently into the fabric of the earth? Down in the hypogeum, the air is different. It's cool, but more than that, it's still. You're in a space cut from the limestone itself. It feels huge and also close. This isn't a natural cave, it's a mirror. A perfect copy, but upside down, of the stone temples up above in the Maltese sunlight. Except here, everything is carved down into the earth. The builders 5,000 years ago, they didn't build up, they carved away. They revealed a sanctuary on 3 levels, a whole world underneath the world. The planning itself is the first thing. To carve a multi-story place in this soft limestone, they had to think in 3 dimensions. They had to think in negative space. They started from the top. They hollowed out the upper rooms first. Then they carefully dug stairways and shafts down to the next levels. And all the while, they left parts of the rock behind to hold everything up. Pillars, arches, lintels, all carved from the original stone. One mistake, one pillar made too thin, and the ceiling would have come down. This was architecture underground. It needed a deep understanding of weight, of stress, of what the stone could take. They engineered for stability in a material that could crumble. The chambers echo the sacred spaces above. They mimic the curved walls, the doorways, the altar niches from the surface temples. It's like the builders wanted to bring the entire ritual landscape inside, into a controlled, permanent dark, and they decorated this darkness. On the walls, you can see traces of red paint, swirls, patterns, maybe symbols. This was a painted sanctuary, a place of art and ceremony deep in the earth. Then you come to the oracle room, and the space speaks, or it sings. The room is small, but the sound inside it is enormous. A deep voice chanting at a certain low note makes the whole room resonate. The vibration moves through the stone floor and up into your body. You feel it. This isn't an accident. The curve of the walls, the size of the niche, they create a resonant cavity, tuned to the range of the human voice. During a ritual, the effect would have been transformative. A chant, a drumbeat, could fill the whole complex, felt as much as heard, creating an atmosphere that was immersive, otherworldly. This is ancient sound engineering, a deliberate design to amplify spiritual practice, to use vibration as a tool for ceremony. So what were they doing here? The hypogeum was a sanctuary but also a resting place. They found the remains of thousands of people in its chambers. It was a collective burial site. The acoustics add a layer to that purpose. Rituals for the ancestors, chants to guide them, would have been by the architecture itself. The space became an instrument, a tool to bridge the world of the living and whatever comes after. The hypogeum is a unique convergence. It brings together architectural daring, artistic expression, and a sophisticated, intuitive grasp of physics. It shows a culture thinking as a whole. They didn't just dig a hole, they composed an experience. They shaped stone to shape sound, to shape ceremony, to create a permanent vessel underground for their most profound beliefs. In its silent, resonant dark, it holds a question, not just how they built it, but why they needed it to feel this way. What did they hear or feel in that engineered vibration that was so essential to their understanding of life and death and the sacred? They turned mountains into a garden, a staircase of 10,000 steps, each one a pool of water holding the sky. These are the rice terraces in the Philippine Cordilleras, a landscape reshaped by human hands over 2,000 years. It's a different kind of engineering, not moving megaliths, but the patient, generational sculpting of Earth itself. The Ifugao people didn't build a structure. They built an ecosystem. The scale is hard to grasp from the ground. From above, it becomes clear. The terraces cover about 4,000 square miles. They follow the mountain contours, but they impose a new geometry. Each level is a perfectly flat field, held back by a stone wall or a wall of packed earth. And these walls are the silent part of it. They keep the soil, built up over centuries, from washing down the slope with the rain. It's erosion control on a geographical scale, a battle against gravity fought with simple materials and a deep understanding. But the stone walls are only part of the system. The real genius is in the water. The whole complex is fed by an ancient irrigation network, a web of canals and bamboo pipes. It starts high up in the misty rainforests above the terraces. Those forests act as a natural reservoir. They capture the rain and release it slowly all year. The Ifugao channel this water from the highest terrace down, using gravity to cascade it from one level to the next. Each field floods in turn to nourish the rice, and then the overflow continues downward. It's a closed loop, a sustainable circuit designed by observation and refined over countless seasons. They engineered not just the container, but the life inside it. This knowledge wasn't in books. It was a living tradition, passed from parent to child through the rhythm of the agricultural year. The community's social structure, its rituals, its identity, became tied to the maintenance of the terraces. Repairing a wall after a storm wasn't just a chore, it was a duty, to the ancestors who built it and to the generations still to come. The terraces needed constant collective care. That created a culture of stewardship, where the health of the land was the health of the people. The result is a kind of harmony. The terraces aren't an imposition on the landscape, they're a collaboration with it. They turn a steep, erosion-prone mountainside into a productive, stable, beautiful food source. For 2,000 years, this system has sustained the Ifuga without depleting the environment. It's one of the most enduring examples of sustainable agriculture. That longevity asks a question of our modern world. In an age of industrial farming and ecological challenges, what can we learn from this 2,000-year-old design? The lesson isn't in copying the terraces. It's in the philosophy behind them. A philosophy of observing natural systems, of working with gravity and water flow, not against them. It's about investing in long-term stability over short-term yield. And maybe most importantly, it's about embedding the value of preservation deep inside the culture, making the care of the land a central, non-negotiable part of being a community. The rice terraces are a living monument, not a relic of a finished past. They are a continuing conversation between a people and their place in the world. They show that the most advanced engineering isn't always about creating something new from raw materials. Sometimes it's about listening to an existing landscape, and with patience and wisdom, helping it reveal its most abundant, sustainable self. After a journey across structures that gravity and time, we end here, at a mountain that feeds its people. It brings us to a final, quiet wonder. One that asks not how we move the earth, but how we learn to truly live with it. The bluestones have their own story. It's a story about distance. The big sarsen stones, the ones in the outer circle, those came from just 20 miles away. But the smaller bluestones inside, those came from much farther, over 150 miles, from the hills in Wales, all the way to Salisbury Plain. About 4,500 years ago, a Neolithic community decided to bring those specific stones that whole way, across mountains, across rivers, across open sea. And it wasn't just one stone, it was dozens. Each one could weigh up to 4 tons. To move a 4-ton block of rock that far, without wheels, without metal, just wood and rope and human strength, that's a staggering feat of logistics. The route was probably a mix, part land, part water. They, the stones in Wales, then likely dragged them on sledges, maybe over log rollers down to the coast. From there they could have loaded them onto rafts or tied them between canoes for a voyage along the coast, crossing the Bristol Channel. Then another long haul overland across what's now England. Every step of that required coordination, planning for tides, for river levels, for the strength of the teams. It was a project that would have taken years, maybe generations. A sustained focus that goes beyond what we usually think of for Stone Age people. This wasn't a random choice. They had local stone right there on Salisbury Plain. So why go all the way to Wales? Geology gives us a hint. The bluestones aren't just rock, some have a spotted look, and when you strike certain types they ring, a clear, almost metallic sound. In a culture built on oral tradition, stones that could sing might have been seen as special. As vessels for a voice, maybe the earth's voice or the ancestors. There are other ideas too, old beliefs about healing, about the springs and stones in the hills having power. The bluestones might have been considered powerful in themselves, so bringing them wasn't just about moving building material. It was about moving a sacred essence, translating the power of a distant, holy landscape to this new ceremonial center. The whole operation points to a society with real project management. To keep this effort going, they needed social cohesion, leaders to organize the labor, systems to feed the work teams, a shared belief so strong it could motivate people to spend their lives moving mountains one stone at a time. The bluestones, once they were up, were arranged and rearranged over centuries. They were the heart of the monument long before the giant sarsens framed them. Their journey was the original act, the defining act of Stonehenge. So the image we're left with is this. Neolithic people under open skies, chanting as they pull a great stone on a sledge, guiding a raft through choppy water. This isn't primitive. It's sophisticated, long-term engineering done with Neolithic tools. It's a testament to human will, to holding a vision across a vast distance and across time. The bluestones anchor Stonehenge not just to the earth, but to a specific, faraway place of power. Their presence turns the monument from a local wonder into a statement of connection. A declaration that the sacred could be sought from beyond the horizon and brought home. They remind us that the greatest constructions often start with a journey, and the most enduring mysteries are carved not just in stone, but in the sheer length of the path taken to bring them home. So many stones, so many stories, but after a while you start to hear the same things. Across the world, across thousands of years, these aren't random. They're echoes. They're having the same conversations over and over. The first one is a conversation with the sky, the pyramids pointing north, temples in Malta built to catch the light on a specific day, the lines only seen from above. There's this drive to connect what people build to what happens in the heavens. It wasn't just about knowing when to plant crops, it was a statement that human order should mirror cosmic order. And to do that, you needed more than just looking up. You needed a deep, often mathematical understanding of cycles. Knowledge so precise you could build it into the direction a city faces, or the slope of a stairway for. Then there's the conversation with the earth, not just using the ground but working with it as something alive. The walls they're built to sway with earthquakes. The stonework in Great Zimbabwe, the roads of the Inca, they're made to flex and settle. The builders didn't fight the land, they listened to it. They built for resilience, using shape and weight to make things that last where rigid modern construction would fail. That means they understood the earth, they understood physics. An understanding earned not in a lab but over generations, trial and error, watching closely how the world actually moves. And then the most obvious thread, moving mass. The huge stones in Malta, the 1,000-ton block at Baalbek, the giant granite boxes in Egypt, cultures with no contact, all facing the same problem, and they all solved it. The methods might differ, levers, ropes, water, maybe even sound, but the result was the same. A control over material that still surprises engineers today. That points to a lost science. A practical knowledge of leverage and balance so ingrained it became tradition, passed down in the work itself. Maybe the most striking theme is the planning, the grid of the sewers of Mohenjo-Daro, the entire underground city. These projects required a vision that went beyond a single lifetime. They needed a society organized enough to carry that vision forward, and a technical language, standard bricks, uniform tools, modular stone, to make sure it was done the same way every time. This isn't the work of simple tribes. This is the work of societies that could think in centuries. So what does this pattern tell us? It challenges a simple story, the story of steady progress from primitive to advanced. These sites suggest something else. Peaks and valleys, local bursts of knowledge that achieved a specific profound mastery. That knowledge was practical, rooted in a place, carried in tradition, not books. And it could be lost, it was fragile. A change in climate, a collapse, a new belief, and the know-how for moving mountains or reading stars could fade into myth, leaving only the stones behind. This doesn't mean there was one global lost civilization. The differences are too many. But it does mean something just as significant, that the human mind, facing the same basic challenges, tracking time, surviving disasters, building something sacred, creating community, can arrive at very similar, very sophisticated answers, on its own. Through observation, through ingenuity, through collective effort. The legacy of these places isn't a single puzzle with one key, it's a mirror. It shows the latent potential in human societies, even ones we call primitive. It shows that advanced capability isn't unique to the modern world. It's a recurring human event, a reminder that knowledge isn't a permanent possession, it's a flame. It has to be tended and shared and built on, or it can go out and leave behind mysterious, magnificent stones for someone else to find and wonder about. The journey ends with a simple truth. Our ancestors weren't waiting to become capable. They already were. They were masters of their world. From the deserts of Egypt to the mountains of Peru, these 30 structures, each one is a signature. It's the signature of a society that saw a problem, how to move a mountain, how to track the sun, how to build something that lasts forever. And they found an answer, a breathtaking answer. They show engineering that still inspires architects today. It still baffles engineers. These aren't anomalies, they're evidence. Evidence of a human ingenuity that was always there. It was just waiting for the right conditions, the right belief to express itself in stone. What they built is a global testament, a testament to ambition, sure, but more than that, it's a testament to observation, to a deep, patient conversation. A conversation with the materials of the earth and the patterns of the sky. This legacy tells us something. Our historical record has silent chapters. The story of human innovation isn't a straight line. It isn't a smooth path from primitive to advanced. It's a complex, branching narrative, full of peaks of forgotten genius, and valleys of lost knowledge. It's far more wondrous than any textbook could ever convey. Reflecting on this invites a kind of humility, a necessary humility. It asks us to shed an idea. The idea that older means simpler. We have to recognize that the people before us weren't primitive. They were profoundly capable. They had a different set of priorities, a different kind of wisdom. They invested generations in projects whose full purpose we can only guess at. They were driven by beliefs we're still piecing together. Their success challenges our modern arrogance. It suggests something. That advanced capability isn't defined by the complexity of your tools. It's defined by the depth of your understanding, by the strength of your collective will. So let this exploration be a starting point. A door opened, a door into the vast, mysterious landscape of our shared heritage. The past isn't a closed book, it's an ongoing conversation. And these silent stones, they're its most eloquent speakers. They wait for us to listen, to question, and to wonder.